Well, thank you all for being here. And my name is Rajen Sheth. I'm the CEO and co-founder of Kyron Learning. Just to give you a little bit of background and context on why I'm here. Kyron Learning, we're a fairly new company, about 2 years old. We're focused on building out video-based discussion AI solutions. And so these are videos that you can talk to and interact with that help students be able to get the support that they need in classes. And so we're using a lot of generative AI technologies. Context on myself, previously I was at Google for about 17 years, and my last stint there worked on and led the AI team for Google Cloud. And so one of the things that I've been thinking a lot about over the past several years, especially as AI has really developed, is, one, how do we use AI responsibly? And then two, how do we all really get a good baseline understanding of what is AI, how can it be used well, all of those kinds of things. And it's especially important in education. And I've seen that in education in particular, we've seen a bit of a trend that people are scared of AI, partially because it's very tough to figure out what this is and how can you use this safely and responsibly. And so what I want to do with this session is you all should be able to know 4 things from this. One is the fundamentals of how AI works. 2 is how to best use generative AI in education and how best to control it. The 3rd is the major risks of AI, and what are 3 questions that you can ask every time that you're using an AI tool to make sure that this is something that's safe for you to use. And then the 4th is to give you a little bit of a preview into the future. What are 3 innovations that are going to happen over the course of the next year that you should be looking out for with AI? Now, this is meant to be kind of like a 101 level class, effectively. But that said, I've delivered the same presentation to boards of directors of very large Fortune 500 companies. And what's interesting is that even those that have been in AI, it's even tough there to have a baseline of what AI is. And so, so I want to take you kind of through that grounding all the way through to how this can be used. So let's start with the fundamentals of AI. So 3 things that we're going to talk about. How do you use AI today? How are we all using AI? How does it work? And then why is there so much talk about it right now? So quick show of hands, how many of you think that you have used AI in the last 24 hours? How many of you think that you've used AI every day for the last 5 years? And the truth is you all have, and I'll talk a little bit more about that. So what's interesting with AI is that we're in a very interesting moment. How many of you remember this? a few in the room. There we go. And so I might be dating myself a bit, but I saw this first in college, and this is the original Mosaic browser that was released in 1993, and it was really the first time that the world saw the internet. And the internet had been around for a long time before that, about 25 years before that, but then this was the first time that the average person saw the internet. And the reason that I bring this up is that that moment was a seminal moment in computing, and everything after that was different than what was before, and we're in that same moment with AI right now. And in fact, AI has been around a lot longer than that. So this is a picture of John McCarthy, who was a professor at Stanford, one of the original founders of AI. This was taken in the 1960s, where he was actually playing chess with an AI-powered computer at the time. Much less sophisticated, but a lot of the same concepts that are there. But we're now finally, almost 60 years later, getting to the point where AI is actually usable by the average person. And so as I said, you have likely used AI multiple times in the last 24 hours, and you probably have done that for multiple years. So a few examples of this. If you use Google Photos, you've used some of the most sophisticated image recognition models that are out there. So this is a picture, this is an example of me looking for pictures of my kids in the mountains. It's recognizing who my kids are. It's recognizing where the mountain is. It's bringing all that together using these AI models. This is, if you've used Siri or Google Assistant or Alexa, you've used AI in the last 24 hours as well. And so this is using some of the most sophisticated speech recognition models and natural language models. If you've looked up what's your chances of your team winning in the NBA Finals, you've used AI. So this is from ESPN. What it's doing is using predictive AI to be able to take in a variety of data points and generate a prediction. If you've unlocked your phone, you've used AI. This is using some of the most advanced facial recognition algorithms that are out there. If you use Google, you're using AI. A lot of Google search is built on top of AI. And then, of course, if you've used things like ChatGPT, you've used AI. This is the newest form of AI with generative AI, and we'll talk a little bit about, how does that compare to the other parts of AI. So I want to talk a little bit about how does this all work. So question for everybody. If you look at this picture here, can anyone tell me where this picture is taken? Very nice. There you go. Very specific. So I take it you're probably from New York or have lived in New York. And so, so it's interesting to hear that answer because different audiences, some people don't recognize it at all. Most people say this is in New York. And if you think about why do you know that? Sorry? Sorry? No, well, no. This is New York. That is correct. It probably is exactly where you're saying it was. Now, the thing about it is that people recognize the Empire State Building behind there. And if you think about why do we recognize that this is New York, you look at that, you've seen the Empire State Building. You have never seen this apartment before, but you recognize that, and you're making a probabilistic guess that this is in New York. And if you've lived in New York, you have even more knowledge. And so what you're doing is you're trained, based on what you've trained yourself on over time, you're able to then figure out where this potentially is and make a guess at that. It may not actually be New York. In this case, it is. For example, you could have a picture there that looks like New York. So you're making a guess. And that is essentially all AI is. It's pattern recognition based on probabilities. People think that it's thinking or it's reasoning, and in reality, all it's doing is making pattern recognition based on probabilities. And it's all probabilistic as well. It's taking things, assessing the probabilities, and giving you the most likely probability. So the most kind of basic form of AI is linear regression, something we probably all learned in school. And this is a very simple graph of car price compared to the age of a car. And if you use all of this, then you can start to figure out a 6-year-old car is probably worth $5,000. This is used quite a bit in a lot of different applications out there, and it's probably one of the most widely used forms of AI. However, we know that this is not sophisticated enough, because if you're thinking about the price of a car, there's so many other factors that you have to think about, like the make and the model. A Hyundai is going to be a very different price than a Ferrari, let's say. The service history, the car type, various things like that. So in more sophisticated AI algorithms, what they do is take all of these things and plug that into a very similar function to be able to figure out the probabilities that are associated with that. But even this is not sophisticated enough because, whether it's a Ferrari or a Hyundai is a much greater factor than the age. And so what you'll do is you can actually multiply each of these by a particular weight and then put it into that same kind of regression function to be able to get to predict the values. But it turns out that if you take it another step, you can get it even more accurate. So if you take that and put it into another function with different weights, and then you combine those together into another function, you end up with a much more accurate answer. And this is what's called deep learning, where what you're doing is not just using one function, you're using many nodes of functions, putting in different values, and then coming out with a value ultimately. Deep learning is probably now one of the most widely used forms of AI that's there. Now, the way that this now works is that a lot of the deep learning algorithms that are out there, you have lots of these functions where you're feeding all of this data into. And in fact, in some of the cases, and we'll talk about this in a second, you have millions of these nodes, billions of these nodes, and it's just getting more and more sophisticated. One really interesting thing about these deep learning algorithms is that you don't have to guess at all of those weights. you can actually train it based on data. So for example, if I, rather than trying to guess at those weights, I took the Kelley Blue Book data and I fed it into that algorithm, the weights can adjust themselves to get to you to the most accurate predictions. And as a result of that, you don't have to go do that manually. You just pump a lot of data into this, and the algorithms become sophisticated and more sophisticated. So the more nodes you have and the more data you have, the more accurate this becomes. Now, this is actually how the human brain operates. If you think about how neurons operate in your brain, it's a very similar kind of a thing. Neurons fire and then feed into other neurons. And this is kind of mimicking that in a lot of ways. Now, there are various different types of AI that are out there. So one is predictive AI, being able to predict the future. So this was the NBA example I was telling you about before, where you put in a lot of different points of data, and then you come out with an answer. The car analogy I talked about, this is a good example of predictive AI. A second one is classification AI, and this is classifying things into a bucket. So I showed you the example earlier of looking at my kids in the mountains. To recognize a mountain, that's what you're doing there is you're using an image classification model where you're looking at an image and you're saying, this is a picture of a mountain, this is a picture of a bunny, this is a picture of a dog. And so you can bucket things together and put that into there. Now, the newest form of this is generative AI. And the thing about it is that it's based on the same kinds of things, but a different type of model where it can actually start to generate information and create new information. And we'll talk a little bit about how it's doing that. It's actually using the same types of things, but using that to actually generate new information. One of the things that was kind of a key moment that has brought us to this generative AI moment happened a few years ago in 2017. This was a paper that was published by a bunch of people, mostly from Google Brain, that published what they call the transformer model. And it was all about this concept of attention. And I won't go into a lot of the details about that, but they found a new way to architect a model by which if you put a bunch of text into the model, it can go generate a bunch of text in a very accurate way that is related to the text that you put in. Now, when we first did this at Google, one of the first things we used this for was translation. And so many of you have used Google Translate. Around 2017, 2018, Google Translate became a lot better. And it's because they started to apply this methodology to Google Translate. This then became the basis of the entire generative AI revolution that we see here today. Google open sourced this, and it's now being used by everybody to be able to create the large language models you hear about. Now, the other thing that's happened in the last few years is that these models have become dramatically more sophisticated. So what you're seeing here is that on one side, you have the number of parameters in a model, and then the other side is time. A parameter, you remember my graph that I was showing you with the car type and the car model? All of those lines are essentially a parameter. And if you count up the number of lines, you have the number of parameters that are there. So back in 2018, you were kind of in the billions of parameters. Now you are at models, so the most sophisticated large language models have 1.6 trillion parameters. So it's doing literally billions of calculations every single time you are doing a query into one of those models. So that has brought us to the precipice of what we're seeing with generative AI. The reason that this is so powerful now is you have incredibly large models trained on incredible amounts of data. And as a result of that, you have very, very powerful and accurate things. So let's talk a little bit about generative AI. So what can you do with it, and then how do you control it? So the way generative AI works is actually pretty simple at the end of the day. What it's doing is it's taking a bunch of text, and then it's predicting what is the next word that you have after that. And it's a little bit more sophisticated than that. There's a thing called a token that is trying to predict. But basically, the way you can think of it is predicting the next word. So if I think about a term like this, once upon a blank, what do y'all think the next word would be? There you go. And the reason that you know that is that you've seen nursery rhymes your entire life that always say once upon a time. So it's not going to be once upon a like bottle of water or anything like that, right? So it's once upon a time. And then if you have once upon a time, there was a magic blah, there it's a little bit less clear. But what you can do is you can use the context of what you had before to try to figure out what's best there. So it's probably not going to be once upon a time there was a magic car, because a lot of the nursery rhymes are fairly old, and they may have something about a magic castle or things like that. So the most likely word is going to be something like castle, let's say. And so all it's doing is going word by word and predicting, and then putting the rest of it back into it and predicting the next one, and the next one, and the next one, and the next one. That is how something like ChatGPT actually creates the responses that it's doing. Now, turns out, just by doing that, you can do some amazingly sophisticated things. And so some of the things that we've seen people use generative AI for, of course, are things like drafting an email or drafting a letter, organizing a travel itinerary, summarizing an article. AI is getting very, very good at summarization. And so you can start to do things like that. You can create website content using AI. You can research a topic. And this is something that you have to do with caution, because remember, this is a probabilistic algorithm. So it is always going to be wrong a certain percentage of the time. And so anytime you're using it for things like research, you got to make sure that it is actually accurate. You can simplify a complex idea. You can take an idea or a piece of text and say, how would you explain this to a kindergartner, for example? Or you can do things like write code. It turns out it is very good at writing code because it's been fed with a lot of code examples as well. So in education, there are a lot of places where this is now starting to be applied. And I mean, you can see that from all the stuff you've seen at this conference here. But I think 4 key categories, and this is actually by Reach Capital, a really good kind of first map. And this is changing literally by the day in terms of the companies that are there. But study tools, virtual tutors, kind of teaching assistants and co-pilots, and mental health and SEL, I think, are 4 key categories that you're seeing companies start to build in. And these are a few of the examples of the kinds of companies that are there and the types of applications that are there. And like I said, if you go over to the AIR Show right now, you probably have about 20 others that you can add onto this list that are probably didn't exist when this list was created itself. Now, if you boil it down, there are really a couple of key things that, as an educator, you can do with AI. With AI, you can save time for teachers. You can take tasks that are very hard to do manually and start to do it more automatically. So, for example, you can do things like create a rubric. You can draft an IEP. You can re-level content for another grade. You could create a lesson plan based on AI. You could create a quiz. You could build a worksheet. Or you could even draft things like student feedback. And so there's a lot of interesting things you can do that will save you time as a teacher. A few examples of that, Magic School AI, I think, is a very good example of this, where they have a bunch of teacher-facing tools that make tasks like these very easy for a teacher to be able to do. And then there are many others that are similar to that as well. The next frontier is that you can differentiate learning for students. And so we think about this. This is kind of like climbing Mount Everest. We've talked about personalized learning for kind of forever. I think we're now at the precipice of being able to do something where we truly can personalize learning. We can differentiate learning for every learner that's out there. But it is a very tough task because, one, how do you make sure you understand enough about the learner to be able to do this, and how do you do this accurately? And so this is the key area that my company is focusing on right now, is to try to figure out how do you actually do this in a way that is informed by educators. And so a few examples of where this is happening. Amira Learning is a great example of this, where they're focusing on AI for reading specifically, especially early grades reading. And I think this is a key area where there's a lot of need as well. With Kyron Learning, we've been doing this in a variety of areas, starting with math and then now focusing on just about any topic there, which is how do you create lessons that are informed by educators and built by educators that you can put in front of students to help them where they need help in particular areas. We have a solution by which an educator can create a lesson and then a student can pick any educator they want to be able to learn from. And so it's, again, kind of a way that is really informed by educators. And of course, you have things like ChatGPT that are out there. And we have many, many, many students that are using that. And I think that one of the things to look at there is where can you use a more generic tool like ChatGPT versus where you want to use a specific tool that is really focused on education and is tuned for education. Now, one of the big questions here is how do you control generative AI? I'm sure most of you have used ChatGPT, and what you can see is that sometimes the answers are good, sometimes they're not. Sometimes, especially if you think of education, they're pedagogically sound. Other times, they're definitely not. And so there are a few ways that you can think about controlling this AI. So one way to do this is by writing a prompt. And so what a prompt is, it's very simple. It's basically what is the text that you're putting into ChatGPT that then goes and produces things after that point in time. And so this is something that is actually a big breakthrough in AI because this is something anybody can do. If you know how to write English or any other language, you can write a prompt, which is pretty dramatic. The reason that that's so dramatic is that 8 years ago when I started working on AI, you needed to really be a PhD in AI to really know how to build things with AI. Now, all of us can build things and customize things with AI because it's as accessible as writing things in English and writing a prompt. Now, that will get you actually a surprising distance of the way there, just by writing kind of more and more sophisticated prompts. Those prompts can get incredibly sophisticated, and you're seeing people do some pretty amazing things with it. So then the next kind of more sophisticated way to do this is what's called retrieval augmented generation. I just realized I made a spelling mistake there, but retrieval augmented generation, also known as RAG. Fewer people are able to do this because it does involve a lot more kind of coding expertise to be able to do this. What the concept of this is that rather than always just writing stuff and putting it into something like GPT or into Gemini or into any of the other models, what you're doing is you're dynamically pulling the right data and putting that into the prompt. And so let's say somebody is asking a question about fractions, let's say. What you could do is if you have a database of information about fractions, you can pull something from that database and plug that into the prompt along with the question, and it makes the algorithm smarter and makes it such that it's more focused. You can see from, remember the once upon a time thing, the more information you put in there, the more accurate it becomes. This is actually something that is now very widely used, and it's probably the most common way that people are controlling what generative AI spits out. A third way, which is also now becoming more common, is fine-tuning. And this is where you actually put more data into the model. So remember we talked about how the model that we had at the very beginning, you could train based on Kelley Blue Book data. You can use what's called fine-tuning to be able to take additional data and train these models. So let's say you have curriculum data or you have data about a particular thing, you can fine-tune it. It's a little bit harder to do because you do need to have some coding expertise to be able to do it. Now, the most sophisticated thing is to go and train a new model. And there are now open source models where you can just take a model off the shelf and start to train it with your own data. This is a much tougher way to do it, but you do get a lot of advantages if you do it this way. You could potentially get to better accuracy in some cases. You can also get to lower cost. It turns out in most cases right now, people are finding better accuracy with the larger models, with GPT, with Gemini, with Anthropic and things like that, than if you go and train an open source model. But this is something I think you're going to see more and more of. So now we've kind of gone through what can you use generative AI for and how do you control it. Then the next big thing is the risks of AI. And there is a lot of talk about, okay, is is AI just going to go take over the world and things like that? We are far from anything like that. Remember, this is just doing pattern recognition based on probabilities. But there are some very interesting key risks that are there. One of the things that people talk a lot about is job loss. And it's interesting because I think that there is a very good potential that this isn't actually going to be a key threat over the course of the next 10 years. This was a very interesting study by McKinsey where they looked at different professions to see what is AI going to do to that profession over the course of the next 6 years. And what you can see is that in most cases, the number of people employed in these professions is going to continue to go up over the next 6 years. It's just what's going to happen is that part of their job is going to get automated. And what that will do is that it'll make people more and more efficient so they can be able to do a lot more in the course of a particular number of hours. So you can see, for example, of course, in education, there's a big question about will teachers be automated by AI? And you can see here the number of teachers is going to increase over the course of the next 6 years, but teachers will be able to be more efficient with what they can do with AI. There are definitely places where you are going to see job loss. So you can see, for example, things like customer service reps and things like that. There is definitely areas which will get more automated, but by and large, we think that AI is going to make people more efficient. There are 3 big areas, though, that you really should make sure to watch out for: accuracy, bias, and unintended consequences. And these are 3 areas to think about a lot. And I'll go into each one of these. So accuracy, this is actually a little bit dated already. What's happening now is that this is changing literally on a weekly basis. New models are coming out that are getting more and more accurate. But you can see what this is the accuracy of the various GPT models for different subjects. And you can see that it's gotten more and more and more accurate over time, but then there are definitely places where it's 80%, 70% accurate. And what that means is that 20 to 30% of the time, it is not accurate. And so this is something to really think about. And part of how you can control this is find people that are going the extra mile to be able to use data to make these things more accurate via things like prompting or fine-tuning that makes these more accurate. One thing to recognize is that other forms of AI are more accurate right now because they've been around for a lot longer. This is an example of this. So there's a contest every year called ImageNet, where basically people try to take a sample of millions of images and then be able to evaluate those images with new algorithms that they put in to try to figure out, are those images being classified correctly? And you can see that this has gotten better and better and better over time, such that it is now over 90% accurate. And you're going to see the same thing happen with every one of these AI algorithms. A second thing is around bias. And this is a very tough thing to figure out because the bias is based on the data that you put into the algorithm. So really, it's kind of garbage in, garbage out. So for example, if we look at things around like medical data, for example, if you're putting in discriminatory data into this, it's going to blend that into the algorithm. That's going to actually create biased practices. That's going to create more biased data, and then that gets put back into the algorithm. And so you're going to kind of have this self-perpetuating cycle. So this is probably one of the most dangerous parts to try to really figure out. And so figuring out what data are these algorithms based on is really critical to be able to figure that out. A third thing is around unintended consequences. And so part of this is about the AI, but a lot of it is about where you apply the AI. And so I'll give you an example of this. So facial recognition. All of us use this on a daily basis to unlock our phones. Now, let's say that for some reason it didn't work and it didn't unlock your phone. It's not that big a deal, right? You can enter in your code. You can unlock your phone other ways, right? So the consequences are not very high. However, one of the big controversies out there is using AI for example, surveillance and things like that. And being able to do facial recognition based on that. it turns out that especially facial recognition for people with darker skin is actually not as good because of the data that a lot of the algorithms are trained on. And so in those kinds of situations, you can end up with really, really bad consequences. And so you have to really start to look at, what is the downside of it being inaccurate. So that really then boils down to a few of the questions that you can ask about this. So question number one is, what can I do when the AI is inaccurate, and how often is that likely to happen? And so that's, I think, a key thing to really think about, because it will be inaccurate at various different points of time. How do you build the process around it in terms of where it's used such that you can have a reaction when it's inaccurate? The second thing is, how is it guarding against bias? This is a tougher thing to ascertain, but then there are things like, for example, the new Common Sense Media ratings of different applications out there, where you can go and see, how are they doing things, what is the data it's based on, things like that, so you can start to get more information that way. Third is, what are the unintended consequences? How are you using AI, and what are some of the consequences that might happen as a result of this? And so these are really the three things to keep in mind that you ought to ask when you're using an AI tool. Now, in education, I believe that the teacher is the key to safe AI for students. So having the teacher be a part of this is going to be really, really crucial, because the teacher can then be able to help judge and help moderate what's good for the student, both in terms of judgment, pedagogical accuracy, things like that as well. And so a lot of folks, us included, have been really focused on how you can empower teachers with AI, and I think that's going to be a key thing. So the last thing I'm going to talk about is key innovations over the next 12 months that you're likely going to see. And this is a moving target. So since I actually built this presentation 2 weeks ago, a whole bunch of things have gotten released that now actually you can add to this list as well. And so literally this is changing on a weekly basis. So, but the broad strokes are that AI is going to get more accurate. That's one thing. This is something that was published by Anthropic that talks about their new model in comparison to other models that are out there, and looking at kind of the accuracy of those things. So you can see in a few areas, AI is incredibly accurate. So if you're looking at things like multilingual math, for example, it's very accurate, or knowledge Q&A, it's very accurate. However, in other areas, there's still a lot to be done. So there are areas of math where we're looking at like 60% accuracy, and so there are definitely things like that are very not sophisticated yet, that are going to get more accurate. This is something that was published just a couple of months ago, and it's probably already out of date. There are going to be more things that will get published, more and more model updates that will get published that are going to make this more and more accurate over time. GPT-5 is one of the things that's going to be a key big step here over the course of this year. That's something that will potentially take this to yet another level. But there are also others that are out there as a part of this. Gemini keeps evolving, and you're seeing multiple updates of Gemini from Google that are getting more and more and more accurate. Anthropic just put out a bunch of things as well. And so you see this kind of race to get to better accuracy at lower costs over time. Which then brings us to the second thing. AI will get less expensive. It is actually very expensive right now to use generative AI. But then this will get less expensive. And there are a few things that are going to cause this. The first thing is specialized hardware that's running in the computers that is focused on AI. So NVIDIA has really done a great job at this and started to actually build chips that are very specific to doing calculations that are associated with AI. And that makes it such that AI can be done a lot more efficiently. But you're seeing a lot of investment in this area, and then that's going to make it such that especially these large language models are going to get less and less and less expensive to run. Now, another big thing that you're going to start to see is things like distillation. And what I mean by distillation is, how can you take what's in a very broad model and then train a smaller model based on very specific data? Now, the broad models like GPT-4 are useful for when you're asking random questions about a lot of different things. But what if you want to create something that is really good about Greek history, let's say? You could do that by taking a smaller model and training it with a bunch of the data from a larger model. That makes this a lot less expensive to run. And so you're seeing people do that more and more to be able to get to a lower cost point as well. A third thing is open source. So there are a lot of examples of open source models that are now out there. So Google released one with what's called Gemma, which is essentially kind of an equivalent to Gemini, but an open source model. Meta was one of the first that did this with Llama. And then Mistral AI is a French-based company that's doing a lot of this. And so what you're going to start to see is that people are going to use these types of models and start to train them with their own data. And it's much less expensive to run these models than it is to run some of the big ones that are out there. The third thing is that AI will become multimodal. And so right now, what you've seen a lot of is AI focused on chatbots and text. And AI is going to become a lot more multimodal, where it'll be able to take in things like voice, or take in pictures, or take in a variety of different inputs or video, and then spit out voice or video or images or whatever it might be. Gemini is probably one of the most sophisticated at this. It's been built natively for that multimodal use case. And so as a result of that, you're going to start to see really interesting things that are happening with images that it can create and things like that. Now, we want to hit the video on this one. There we go. So this is an example of OpenAI's new model around what they call Sora. So what they are able to do is you take a small prompt like this, and it creates something like this automatically. It's really fascinating work. And so for things that are artistic, you're going to start to see some really interesting types of things like what you see here, where it can go and create videos for you and do it at really interesting fidelity. Now, we're still a bit of a distance away from a lot of these things being incredibly accurate. You'll be able to see good examples of things like this where it's doing really good stuff, and equal number of things, or maybe even more things, where it's not doing things all that accurately, but this is going to get better and better over the course of the next year. So I'll wrap this up back with this again. And really, we're at a very seminal moment here with AI. And I think for those of you that remember this, you ought to think about, when did the web become something that was really, really crucial to your lives? So for me, for example, it became crucial, oddly enough, I'm a huge sports fan, and so it became crucial when I could see live sports scores on the web. And it started to give me that aha that this is going to be something I'm going to use every single day. We're getting to that point with AI. We are not yet to the point where we've seen the killer applications of generative AI, but we're getting to that point. And so what you're going to see over the next 5 years is going to be similar to what you saw over the first 5 years of the web, where you're going to start to see AI being baked into just about everything that we do. Now, if we all become educated on how to use AI, how it's being created, and how to do it safely, we can then guide AI in the right direction. So thank you all. Really appreciate it. And we have a couple of minutes if there are any questions that folks have. Thank you. Thank you. A question right here?
Yeah, one question. How do you see the space of personalizing the things for students evolving? Like, let's say a student may have their own strengths and weaknesses, right? So that requires a lot of cognition. So how do you see that space evolving?
That's a great question. And so the question that he was asking is that, how do you see this evolving around being very specific to a particular student? And so I think part of that is you have to figure out what are the right inputs that you put in. So when we talk about things like writing the right prompt, a lot of times what you put into a prompt is fairly generic, but then you can also start to put in things that are very specific. So when you construct that prompt, you can start to construct it based on student data. You can start to construct it based on different other parts of data, so that it's generating something that is right for that particular student. Over time, I think you're going to start to have more sophisticated things around this. I think we're signaling that we're switching sessions here, but so I'll leave it at that, and happy to answer any other questions as well. But thank you all.